The name of today's topic is automata. To discuss about the topic, the name of today's topic is automata. Okay, and it's the first topic under the subject theory of computation. In the coming videos, we will discuss all the concepts related to theory of automata in detail. Automata is actually a Greek word, and this word is formulated from the automation, which means machines are designed, and the motive of designing those machines is to replace human beings with machines. Means the motive is uh, to make the life of human beings little bit easier, so that whatsoever the humans are performing, the same things is actually performed by the machine. So let's see the formal definition of automata. Automata is defined as a system where energy, material, and informations are transformed and transmitted, and or you can say used for performing some functions, meaningful functions, without the direct participation of man. So that's the formal definition of automata. So means, as if we will relate it with the machine, or you can say the machine is basically a thing who is performing some functions without the direct participation of man. For example, we are going to take the example of washing machine. Suppose we are taking this time an automatic washing machine's example. So what is actually this machine is doing? We put clothes, dirty clothes in that machine, and will set the timer, or you can say we will start the machine. It will automatically take the water, and and with surf, and you can say with the water, it will clean the clothes and will rinse the clothes, and after that it will spin the clothes. Means it will provide us the clean ones. So in this whole process, the whole working is actually done by the machine, and human's job is just to put clothes and detergent inside that machine. Remaining everything is at the end done by the machine. Automata is actually, or you can say theory of computation is actually a subject whose responsibility is to discuss the theory which is working behind those automatic machines. There are so many automatic machines in the world. In today's we cannot even think about a single thing which is not operated by a machine. Either it's washing machine, refrigerator, fax machine. This time we are living in the world where automatic cars are here. You can say driverless cars are here. So there are so many machines in this world, and every machine has some theoretical model behind that, and this automata is actually the theoretical model which is working behind every machine. Okay, so let's see, in this subject we will discuss these type of automatas, and the very basic type is finite automata. In most of the books, or mostly we will represent this with fa stands for finite automata, and the second one is PDA. PDA stands for push-down automata, and the third one is Turing machine. Most of the times we will represent it with the we are actually representing it with the TM. TM stands for Turing machine. Further, all these have divisions, means subtypes, but currently we are concentrating on the very first thing, which is finite automata, and finite automata is further divided into deterministic finite automata and non-deterministic finite automata. Mostly we will represent it with DFA and NDFA. NDFA stands for non-deterministic finite automata, and deterministic finite automata, in simple term, it's actually denoted with DFA. Okay. Now let's see the block diagram of an automata. This is actually the base which is working behind every automata. So let's see, for example, I am taking the example of a switchboard button, a button which is available in our switchboard. There are lots of buttons available on our switchboards. So let's see one example. There is a button who is responsible to ignite bulb. So initially that button is in the off condition. That means initial state of this button is off. When we will push this button, or you can say press this button, then it will go into on mode. And when it's in on mode, it will ignite, or you can say start the you can say bulb. And same is the case when it's on. When we will press it, it will go into off states, and so on. Same thing is applicable on every, you can say, button, switchboard button. So it's an initial example of a machine, where machine is responsible to ignite any device or start any device, and we are doing it with the pushing the button, means that button is actually a machine. Let's see, slowly we will cover all these things about this switchboard. After some time I will show you the initial diagram, or you can say the graph of that switchboard button. But before that, we will discuss the block diagram of automata. So as visible on the paper, it has first one array sort of thing, and that array is called input file. Suppose our machine have some data to be processed, and that will act as a input file. So we will keep that data inside the input file. Fine. And suppose on and off are actually input and output. Suppose we are representing on with 1 and off with 0, so we will keep this on off inside input file. Okay. And the next one is control unit. Control unit is just like a brain or a control area, where every decision is actually happening. Means after processing some state, what will happen next? Means when we will insert the ATM card in ATM machine, then it will show few steps. It will start the processing, and it will show first step, then second step, then third step, and also meanwhile it will also guide us. Fine. So same here, that thing is actually happening in some control unit. Same thing is applicable here. This control unit consists of so many states, like as I have already written here. mm, Q0, Q1, Q2, there may be any count of states, but initial state will be Q0. In most of the machines, or you can say in most of the books, Q0 is the symbol, small q. Q0 is the symbol used to represent initial state, and small symbols, small English alphabets, or mathematical digits are used to represent inputs. And this is read head. What is the meaning of read head? Read head is actually a head who is responsible to read the content, or you can say read the input from the input tape. And this, the another name of this is also input tape. This is called input tape. And in case of finite automata, I am taking the example of finite automata this time. I am discussing the block diagram of finite automata this time. Finite means having some limit on the input. Finite means finite count of values are stored in an input tape, or in the input file. So that's why these two symbols are represented on the boundaries, or you can so or say that on the last cells of the input tape. These are called end markers. Inside these end markers, the whole input string is actually represented, and these symbols are telling that there is some end limit of these values. Means a finite count of input symbols are written over there. Fine. And the read head will read the input from the input tape based on any function which is working in that machine, or in that automata. Based on that function, it will combine or check it with the state, and will generate and will decide what will be the next state. Okay, let's see. Suppose the state is q naught, and when it will read head will check a symbol from the tape, then it will change the state from Q0 to Q1, and that thing is called a transition, and transition is represented with delta. This symbol is used to represent. Okay, here on this
transition.
paper, I have specified one more thing, that is storage. And storage is actually used in PDA, pushed on automata. So we will discuss, it's just like a memory, a stack for memory. So we will discuss this thing in PDAs. In PDA we will keep some symbols in storage area also. In PDA we will discuss all these things in detail. In automata or in DFA or NDFA case, we will concentrate on this diagram only. This is input tape and these are end markers. End markers means telling the limit of this input file, and this control unit is actually a decision area keeping all the states, and based on the read head or the symbols actually read by the read head, it will decide the next state based on a transition function. So okay, so in general terms, if we will say that in a machine there is number of inputs, there are number of inputs and number of outputs based on the criteria which is actually fitted in that machine. And this is automata who is responsible to decide the you can say the change of states or the movement of states. I will take a little example of an automatic machine this time, washing machine, because initially I took this example. So initially we put dirty clothes in it and we will start the machine. That is the initial state. Okay, and automatically our machine will go in wash phase, in rinse phase, and after that will enter in the spin phase, and after completing all these phases it will give us clean clothes. So at the end all these are states, and every state have some input and will generate some output. This is the initial state with dirty clothes and detergent. After that, wash state will actually wash, means clean the dirt from those dirty clothes, and then the output will be after wash. The output of this phase will be clothes but having detergent in it, clean clothes but with detergent, and that will become the input to rinse phase, and output of rinse phase means there will be uh, wet clothes but cleaned one, and after this will become the input to spin phase, and spin phase will give us dry clothes. So this is actually a simple method, or you can say a simple model which is working behind washing machine. And this is the representation, means every automatic machine have certain input, and based on that input or the functionality which is actually implemented inside that machine, that input will be converted into a next output. A machine can have more than one inputs. If we will take the example of mm, uh, you can say I'm taking the example of washing machine, so this time I will take semi automatic washing machines example. So in that case, in this machine, the machine has two parts actually. The first part is mm, uh, first part is washing area, and the second portion of that machine is spin area. So both have different inputs and both have different working style, and both are giving different output. So this is just a very simple introduction about the automata. So in the as we were discussing about the switchboard, so we will represent in the coming classes, we will represent these machines with the graph, and quickly I will show you the graph representation of this switchboard button. So initially if the button is at the off stage, so this will be the initial state. After taking one input means push, you can also write push here, it will go to next state on. And when we will give it one more push or input, anything you can write, so it will go into off stage. So this is the graphical representation of this small automata, a switchboard button. Getting? So in the coming classes, we will discuss little bit about automata, mean its types, and about memory machine and minimization of automata, etc. So stay tuned with us. Thanks a lot for watching this video, and please like and share this video. Thanks a lot.